So hello guys, what's up? So this is the last question of the contest. Find the sum of subsequences of powers. So this question states that you are given a array nums of length n and a positive integer k, and a power is defined. Okay, so basically in this question, they are asking to give sum of powers of all the subsequences. And power is defined as the minimum difference between any two elements in the subsequence. So essentially, if we have all the subsequences, we can generate all the subsequences, and then in every subsequence, we can check the minimum absolute difference between any two elements in that subsequence, and then we can add it up and then return our answer. But process is that only, but we need to optimize it. Now we can think of generating subsequences, and we can think of dynamic programming to reduce its time complexity. Okay, great. But how are we going to have the hold of minimum absolute difference in any two elements? So one of the approach can be to have a vector. One of the approach can be to have a vector with us every time, and then uh, after whenever the length of the vector equals k, then we can, yeah, we need to generate all subsequences of length k only. Then we can check uh, this minimum absolute difference and can return our answer. But the vector also has a time complexity issues. So now what can we do about it? So we can think of what was our requirement at any particular stage. Just a second. At any, okay, let's say this is our array. This is our array. So at any particular stage while generating the subsequence, I will either pick it or I will not pick it, move to the next index. Now, if I pick it, then I can have the hold of the difference of the previous guy, which I picked it. Yeah. So essentially at a time, I need to have the difference. And okay, so I need the minimum difference only. So what I will do, I will at that time only, we will see in the code, at that time only, I will take the difference. And if it is the minimum difference, then I will update it. So I will need the previous index. Yes. So I will need the current index that though I need. I will need the previous index to compute the difference. And then, yes, I will store the current difference as the, if I am taking it as the minimum of current difference, and this difference I calculated now. And of course, I need a Q. So this is how we can convert this into DP solution and can apply tabulation to it and can go about it. So let's see the code. Now there is one more catch. We can't use a vector, especially to store our current difference. Why? Because the current difference can go up to 10 raised to power 16. And storing such a big thing in a vector is not possible. In a map, we can have key value pairs. So contiguous memory and searching is not a issue. Also, now we need only map for current difference. So why are we using unordered map for all of these things? This is because either you can write your custom hash, or you can't have a vector here. Yeah, you can't have an ordered map of vector or something like that. That will be again a troublesome thing. So this is why we need to have such kind of a thing. So let us see the code. So first we will sort the array. Now sorting the array is also essential. Just a second. So sorting the array is also essential because we are only checking for nums of I and previous index. So I already know that previous to previous index. Okay, so let's say nums of I and nums of previous to previous index will definitely be greater than nums of I minus nums of previous index. So we are sorting prior to it. So let us have a look at the code. So we will have four states: current index, previous index, k, which is given in the question, uh, and a current difference, which we will try to keep it as minimum as possible. Nums and our DP map. So if the k, let's see the base cases. So if the k is 0, so we will initialize k with k only. So if the k becomes 0, then we will return the current difference. As we generated, k0 indicates that we generated a subsequence of length k, and now we can return the current difference. If I becomes n, then there are no more subsequences. We can return the value 0. This is a condition to check. This is a condition of DP. If it exists, if it is memoization condition, if it exists, then we will simply return this. We don't need to solve that again. Overlapping subproblems. Now there can be two cases. Either we take that or we not take that. So if we don't take that, then we can simply have a call for I plus 1 with previous index as that only, k and current difference nums and d. Now, if we are taking it, so it might be happen that it is the first element. So we don't have anything to compare back. That means previous index is -1. So then we will have everything same. Just we took that element. So we will do k minus 1 and previous index as I. Still, the difference will be 1e9 because we haven't subtracted it from anything. Else case, we are taking it. So we will have I plus 1, I k minus 1. But this time we will have minimum of, yes, absolute difference of nums of I and nums of previous index. Current difference, either current difference or absolute difference of nums of I and nums of previous index. So this whole computation we are doing for a particular subsequence. And now what will be our answer? Our answer is the sum of, since we need sum of all the minimum possible values, so it will be sum of take and not take case. So yeah, guys, this was all from this question. Thank you so much, guys, for watching this video. Just in case you like the video, like the question, make sure you hit the like button, press the subscribe button, and share it with your friends. Thank you so much, guys. We shall see you next time.